acidic characters of carboxylic acid. Now in today's lecture, we will be looking at some of the reactions. Before that, let us classify a few things. We have looked, the carboxylic acid is going to be the last acidic functional group that we are looking, and hence we can summarize the acidic strength of common organic compounds in general. Okay, so I will summarize two things. Acidic strength of general organic compounds. So these are classes of compounds, not specific compounds. So in organic chemistry, we talk about alkynes. Alkynes are going to be the least acidic, that is R, with a C triple bond CH. So in this case, this hydrogen, it is acidic. I'm marking which hydrogens are acidic, which can be liberated. Followed by, you have alcohols, ROH. In this hydrogen is acidic. Moving on, you will have water H2O. In this H2O, these hydrogens are acidic, followed by phenol, that is represented by AROH, aromatic benzene, and then you have the OH bond. This hydrogen is acidic, and lastly we have carboxylic acid, that is RCOOH. In this we have the hydrogen, this is acidic. If I compare the acidic characters, and if I am comparing the common groups that are attached to the carboxylic acid group, so acidic strength of carboxylic acid with different groups. Okay, we are attaching different groups here. So the least acidic will be something that is electron donating. So I will say that CH3, CH2, COOH will be least. And then if you have hydrogen attached, that is CH3, COOH, this will be more acidic than the CH3, CH2. Now, next we have the benzene that is attached. So you can write C6H5, that is benzene, which is attached to CH2, COOH. It is going to be more acidic, followed by if you have some electronegative elements such as OH group attached to CH2, COOH. And at last, if you have some more, for example, any halogens, Cl, it's attached with CH2, COOH. So this is the general trend for acidic strength in carboxylic acid. General trend, okay. Now moving on, let us write some reactions in which the hydrogen, that is the acidic hydrogen, it gets used up.
Sir, can you scroll it up?
Yeah, sure.
Okay, sir.
So I'll be writing a series of reactions. Let me start with R, COOH. First is, since it is acidic in nature, what it will do, it will turn the red litmus. So it will turn the blue litmus to red litmus. It will change the color of blue litmus to red. Next is reaction with metals. Metals such as, you can have sodium, potassium, calcium, magnesium, zinc, etc. Okay, so these are what? These are some common metals which react with carboxylic acid. And what do they form? So in this case, I'm taking sodium, and they are going to form R, COO, Salt of carboxylic acid. Salt of carboxylic acid and H2 gas is released, and H2 gas is released. So if you have, for example, if you have zinc, then it will be RCOO whole twice, because zinc has the oxidation state that is +2, and H2 will be liberated. Hydrogen gas will be liberated. Furthermore, it can also react with alkali. Alkali means any base. Because it is an acid, it can react with a base such as NaOH. You can have NaOH or KOH also in NaOH. Again, it is going to make RCOO Na plus water will be released, because this is a neutralization reaction, acid-base reaction. Next, it can also react with sodium carbonates and bicarbonates, like two different reactions. So when it reacts with Na2CO3, you are going to make the same molecule, that is RCOONA. But the byproducts will be different. The byproducts in this case will be CO2 and H2O. Furthermore, it can also react with bicarbonate, that is NaHCO3. In this case also, you are going to get the same molecules, that is RCOONA plus CO2 plus H2O. Okay, so these are the main reactions that is shown by carboxylic acid, in which the hydrogen, that is the acidic hydrogen, it gets reacted. Please write this down, let me know if you're done. Done, guys? Yes or no?
Yes, sir.
Yes, sir, done.
Okay. So the next class of reaction that we want to learn about in carboxylic acid is the involvement of OH bond. So we discussed the last time. We discussed yesterday that there are a few things, few bonds that can be broken. So we are done with the OH bond, right? So we are done with the physical properties, boiling point. Yeah, chemical properties. So in this, we are done with the hydrogen part. This part we are done. We have looked at this bond is broken. Now we are going to look at this bond and what is the reaction, what kind of reaction can carboxylic acid give if the COH bond is broken. If the COH bond is broken, so you can write the topic. A reaction involving the cleavage of COH bond. COH bond. Okay. Now, obviously, if you look at this, then you can see that this is going to have more electronegative character. It is going to have more electronegative character. And if the bond is breaking, if you are going to break this bond, then the bond will be breaking something like this. We'll get C double bond O, and there will be a positive charge here. So obviously there will be something which has a negative charge. That means a nucleophile will be there that is going to attack on this carbon atom to make bonds. Okay. So there are few things that you can make that is involving the cleavage of COOH bond, right? Reactions such as COOH. Firstly, we are going to make simple molecules such as acid chlorides. तो हम लोग के पास यहाँ पे we have R C double bond O and OH. So I have to replace this OH, and OH will leave as OH negative. So something with a negative charge is going to come, and it will be adding up on the, it will be substituting the OH. So right, the first reaction in which we are going to make acid chlorides, we are going to make R C double bond O, and there is Cl. So Cl or X or anything else also. The most common reagent that we use are PCl5, PCl5. Second is, you can also use PCl3. You can also use thionyl chloride, that is SOCl2. All of these are used for the formation of what? For the formation of acid chlorides, for the formation of acid chlorides. You can use any of these three reagents. Okay, any of these three reagents in this first. Either one, or you can use the two, or you can use the third. Next is the formation of esters. Right, next. In the formation of esters, you will have to react this with any alcohol. So we have H, O, and then there is R. Now you can see that this hydrogen, it will be reacting, this OH will be attacking on this hydrogen, and what is going to happen? The hydrogen will be, this OH will attack on hydrogen, and they will be forming water. They will be forming water molecules. Then the carbon and this oxygen will join together, and we will be making, like this R here, R, C double bond O, and this is the O, and then you have R dash. So this OR dash is here. Plus you have made water from the hydrogen of alcohol, and you have made hydrogen of alcohol and the hydroxyl group of carboxylic acid. Okay, all of this reaction, it is done in the presence of an acid. Generally it is H2SO4 or HCl, any proton giving acid. Okay, fine with this one? Yes or no? So you have carboxylic acid and alcohol, it is going to give you ester. Next is, the next one that you have to write is the esterification reaction, or you can also write first of all, let us look at the formation of anhydride. So I have RCOOH, and I will take 2 moles of RCOOH, and I will react this with H plus. Some heat will be there, and in the presence of a catalyst that is known as P2O5, that is an oxide of phosphorus, P2O5. Then what is going to happen? When we have RCOOH, then one of this hydrogen is going to react with the hydroxyl group of the other carboxylic acid that is present, because there will be many molecules, and one of these hydrogen and this OH is going to react, and it is going to form water molecule, and the product that we will be getting is R C double bond O. Then I will have O, C double bond O again, and then we have R. This is known as acid anhydride. Okay. Any problem till here, guys?
No, sir.
No problem, right? So we have formed acid chloride. We have formed next, that is as ester. This is acid anhydride. This is acid chlorides. This is ester. Next, write the reaction that is with ammonia. Now, when you have any reaction with ammonia, then you are going to form a salt, because ammonia is a base. And we have carboxylic acid. Carboxylic acid is what? Carboxylic acid is an acid. So when you have NH3, if you react this with NH3, what is going to happen? NH3 is nitrogen, it will abstract the, it is going to abstract the H from here, and you will have R C double bond O and you will have NH4 positive, and there will be negative sign here. There will be negative sign here. Now, when you further heat this, if you further heat this thing, then what is going to happen? The hydrogen, two hydrogens from the NH4 positive, and this oxygen is going to break off, and you will get RC double bond O and H2. That means two hydrogen from the NH4 positive is liberated out, and the oxygen that was attached to the carbonyl carbon is also out, and they have formed water molecules. In all of these reactions, the byproduct, it is generally water. In this case, that is P2O5, because there is some heat involved. Water is liberated out. You won't see water in the product form because it is liberated out. Now, we have NH3. So first of all, it forms a salt. This salt is known as ammonium salt. Ammonium salt, and here you are making an amide. This is an amide. Okay, any problem till here? Please complete this down. Let me know if you're done.
Yes, sir.
Done, all of you? Yes or no?
Yes, sir.
Okay. Now, this important, that is the esterification reaction is important, and we'll be looking at the rates of different esterification reaction involving different alcohols and different carboxylic acid. Different alcohols and different carboxylic acid. So if I look at these two molecules, we have R, C double bond O, and here we are having OH, plus we have H2O. Let us first of all write the mechanism for esterification reaction, and then we can decide on this, okay? Because when we look at the intermediate, we'll be able to tell what type of substrate is going to give me a more fast reaction. So just write the mechanism of esterification reaction. Okay. First of all, you have carboxylic acid. That means we have R, C double bond O, and there is a OH group attached here. And as you have seen, that esterification reaction, it is happening in the presence of an acid. So first of all, that acid is here. You have H plus. All of these reactions that is involved in esterification, they are all in equilibrium. They are all reversible because most of them are proton transfer. Because H plus, now what will happen to the H plus? H plus will add on this oxygen atom. Okay, this oxygen atom, and it is going to form, this bond will break because it cannot hold, it cannot break also. We'll get C double bond O, H, and O will be positive, and here you will be having OH. Here you are having OH. Now what happens? Now since this is positive, this carbon is what? This carbon is very, very, very delta positive, because oxygen, which is already electronegative, and it has a positive charge now. Hence, all the bond in the pi bond, in the double bond between carbon, all the electrons in that bond will be shifted towards oxygen, and then comes our alcohol. That is R. Like this. H, O, and you have R. Now here, the oxygen, it has lone pair electrons. What it is going to do, it is going to attack on the carbon atom, because carbon is the one which is having delta positive charge, a highly positive charge. As soon as it attacks on carbon and starts forming a bond, this bond will break because carbon cannot have 5 bonds. And you will get COH neutral because it has neutralized now. And here you are having this OH already is present here. You have this OH already present. Now you have one more group that is attached here, which is oxygen is attaching. This oxygen is bonded with hydrogen and it is also bonded with an alkyl group that is R dash here. So this will get a positive charge. Yes or no, tell me. Any problem till here, guys?
No, sir.
No problem. Next, what happens? Next, what happens? Here there is a rapid proton transfer. That means you can see, since this bond is what? A sigma bond, this will be rotating very fastly. So I can write it like this also. It's not an issue. R dash, and here you are having hydrogen. Now this is positive charge. So this hydrogen will be what? It will be having a highly delta positive charge since oxygen is going to pull up all the electrons, and in comes this oxygen. It is going to attack on this hydrogen because it is what? It is very electron deficient. And we are going to make R COH, and this electron is going to shift towards oxygen. You will get OR, and here you are going to get oxygen, hydrogen, and then positive charge. Then this here you can see that there is a formation of, here you are getting the formation of water. So water will be leaving out. So minus H2O, and you are going to get R C positive, OH, and OR. Correct, guys? Yes or no? Tell me.
Yes, sir.
Yes. Now, as soon as this is formed, now this will be forming. You can't isolate this item, this intermediate that I have drawn, because as soon as positive charge will be developing here, there will be lone pair electrons in oxygen atom here only. So as soon as, wait a second, this arrow is wrong. This bond will break like this. This oxygen is going to give electrons to carbon atom because it is developing a positive charge. And if you have a lone pair that is attached to a positive charge, it automatically generates a pi bond. Because electrons are what? Negative. And here you have positive. So negative, positive, they will react and they will be forming R, C double bond O. There will be H. And here you have OR. There will be a positive charge here. Now the acid that was used as catalyst will be taken away. Minus H plus, and we are going to get an ester. OR dash. This is our ester. So please write this mechanism. So in this reaction, the major step is this step, because in this the attack of alcohol is happening on carboxylic acid, and as you can see, it has nothing to do with acidic or basicity of alcohol and carboxylic acid. Mainly is the attack happening or not happening, and that is why the rate of reaction is mostly dependent on the steric hindrance. If the alcohol and carboxylic acid, if they are small, they can easily collide with each other and do the reaction. If they are very bulky, they are going to cause some steric hindrance. There will be some steric hindrance and they will not be reacting. So please write this down. Done, guys? Yes or no?
Yes, sir.
No, sir. The
Okay.
last step.
Okay. Done till here, right, Fatima?
Yes, sir.
Second, right? The rate of esterification reaction depends on the steric hindrance. Steric hindrance. And what is rate? Rate is inversely proportional to steric hindrance. And hence, if I compare alcohols and carboxylic acid, if I am going to compare alcohol, then 3-degree alcohol will be the slowest, followed by 2-degree alcohol, followed by 1-degree alcohol, and then followed by methyl alcohol, that is methanol. This is what? This is 0-degree alcohol. No? See, if I'm going to compare the carboxylic acids, carboxylic acid, then I can say if there's a carboxylic acid which is something, let us see like this. This is permanent CCOH. This carbon is attached with 3 alkyl groups. This will be the slowest because it is most sterically hindered, followed by R2 that is attached to CH, which is attached to COH, followed by R, CH2, COH, and then followed by CH3COH, and the fastest will be for methanoic acid, HCOH. This is the order of carboxylic acid and alcohol. Done, guys? Yes or no?
Yes.
Write the rates. Let me know if you're done.
Done, sir.
Done, all of you?
Yes, sir.
So right next. So let me give you some questions. Please make the compounds. है ना? I hope you have these reaction. I'm going to give the same conditions. है ना? जल्दी जल्दी आप लोग first product बना लीजिए. It's going to be small questions. Write the major products. Okay, write this down. Listen if you're done. Then we'll look at different class of reaction, and in that there will be reaction involving the carboxyl group. That is the COOH group, the whole group.
Yes, sir. Done.
Done? Okay. So in the first you would have just replaced the OH with
Cl.
very good. In the second, you will just have made same
Ester.
thing and then OCH3. Yeah.
OCH3.
And in this case, you will have replaced the OH with NH2.
Yes, sir.
Correct, guys? And
Yes,
in
sir.
this case, you have replaced double bond O, and there will be oxygen, and then 1, 2, 3 carbons once again. So here you'll be having double bond O. This is anhydride. This is acid anhydride. Okay, all of you got the products? Yes or no? Tell me.
Yes, sir.
Yes, sir.
So right next, that is the reaction involving. So now we have looked at how many reactions. Yeah, so we have looked at this group, this whole thing. Now we'll be using this, we'll be breaking this bond, okay? We'll be breaking this bond here. That is the carboxyl group. The complete carboxyl group will be reacting. So let us write the next reaction. Next class of reaction is like reactions involving COOH group. COH group. Okay. So there are two reactions only. There are only two reactions that you have to learn in the reactions involving COOH group. The first is decarboxylation reaction. So please write decarboxylation reaction, and it is one of the methods of preparation of alkanes. Decarboxylation reaction. So in decarboxylation reaction, you react carboxylic acid. Please write with me. When carboxylic acid is treated with, when carboxylic acid is treated with soda lime, soda lime is a combination of sodium hydroxide and calcium oxide, CaO and NaOH. And here we use a ratio 3:1, sodium hydroxide and calcium oxide. And carboxylic acid is treated with soda lime, gives hydrocarbon. Okay, it gives hydrocarbon. So what happens? You have R, COOH. So you have these two molecules, CONA, NaOH. So if NaOH is there, then obviously carboxylic acid will be converted to the salt, that is R, COONA. And because NaOH is already present, plus there will be another NaOH molecules. There will be many NaOH molecules, and it is happening in the presence of CaO, calcium oxide, and some heat. Calcium oxide and some heat. Then what happens? This is formed, that is Na2CO3. And what is remaining? RH is remaining. So if I have CH3, COOH plus NaOH in the presence of CaO and some heat, then this will be getting reacted and you will be forming CH3 and hydrogen will be attached to it. Okay, so you are going to form an alkane or a simple hydrocarbon with one carbon less than the parent, than the original carboxylic acid, with the original carboxylic acid. Please write this down. Let me know if you're done.
Yes, sir.
All of you done, yes or no?
The last equation, so just a second.
Okay.
Done, sir.
Done. Okay. Now, Next is there is also decarboxylation reaction can also happen if you are doing this in the presence of if you're doing electrolysis of carboxylic acid, then also you're going to produce hydrocarbon. So let us look at that, and that is named as coal-base reaction. So if you look at NCERT now, so there is this word present, coal-base reaction, but there is no reaction given because it is already done in the 11th standard. So they have just referred that coal-based electrolysis or coal-based reaction. It is present in 11th standard. तो आप जाके देख लो, ऐसे करके. Okay. So these things are present. This is also a name reaction that can come in your class. So in this we take potassium or sodium hydroxide. And let me write the reaction first of all. And then we will see what happens. So in electrolysis, we will have some reaction at anode. We will have some reaction at cathode. So basically at anode, what happens? We have 2 moles of CS3, COO negative. There will be some dissociation, right? Ions will be reacting. Now, what happens at anode? What happens at anode? Oxidation happens. So 2 electrons, 1 electron from each CS3 COO negative will be liberated, and you will be getting 2 CS3 COO neutral. Now this COO neutral is going to be very unstable, and as you can see, you are ready to form carbon dioxide. You are ready to form carbon dioxide. So what will happen with a little bit of heat, and if you just wait for a few seconds, you are going to form carbon dioxide. Now, if I'm forming 2 moles of carbon dioxide, 2 CS3 free radicals will be present, and they will be forming ethane. That is CS3. Just wait a second. Let me draw it here. At anode, we will have 2 CS3 COO negative. There will be oxidation, that is 2 electrons will be removed. You will be forming 2 moles of CS3 COO neutral. This is going to form, because this is unstable, this is going to form CS3, that is ethane, plus carbon dioxide. This will be 2 moles of carbon dioxide. This is the reaction that at anode. And at cathode, as we all know what is happening at cathode, we have reduction. So this CS3CO negative, it will be having a counter ion, that is most probably sodium or potassium ions. So you can take 2K positive or 2Na positive, whatever you want. And this 2K positive, it is going to eat up electrons. Each K positive will eat 1 electron, and then it is going to form 2 moles of potassium. Now, since potassium it is in water, electrolysis is happening in water aqueous solution. It is going to react with water, and it is going to form KOH because it is a alkali metal. That means if I add it in water, it is going to form a alkali, that is base, and H2 gas is liberated. H2 gas is liberated. Okay, so this is the reaction that happens. This is the reaction that happens at anode and at cathode. Now, if I want to write the complete reaction, I will write it like this: CS3 COO, CS3 COO, and here you can write sodium or potassium. I'm writing potassium according to this reaction. And if we do electrolysis, then I am forming ethane, plus I'm forming CO2, plus I'm forming KOH, and I'm forming H2 gas. Now, since already KOH, we will have KOH in the reactants only because we are starting with a acid CS3COOH plus KOH, and we are electrolyzing this part. Okay, we are having electrolysis like this. So you can write this: if you have CS3COOK, then in electrolysis you are going to form a hydrocarbon, double the number of carbon atoms. Okay, double the number of carbon atoms. So write this down. Let me know if you're done. the alkane form has double the number of carbon atom, present in the alkyl group of acid. Then all of you?
No, sir.
Okay.
Done, sir.
Ahmed, done? Yes or no?
Yes, sir.
Okay, right, next. So this is all about the decarboxylation reaction. Next type of reaction is the reduction reaction. Reduction. Okay. So in reduction, there are two types of reduction that you can do. You can do partial reduction of carboxylic acid, and it is going to form alcohols. And if you do complete reduction, then it is going to give you alkanes. Simple alkanes. Okay. So number one, I will write partial reduction to alcohol. So in this, we'll be using reducing agent. You will have RCOOH. Now you can use multiple reducing agents such as lithium aluminium hydride. Then what else you can use? You can use lithium aluminium hydride, and you will be using lithium aluminium. Okay, fine. Solvent. This is solvent. Okay, ether is not a reagent. You guys don't need solvent. You can either use LiLH4 or you can also use B2H6 diborane. B2H6. Both of these are going to give you alcohol. And alcohol will be 1 degree alcohol. R CH2OH. R CH2OH. Now you can see what has happened here. C double bond O, and here you have OH. So the CO bond has been reduced to CH2 bond. CO bond has been reduced to CH2. C double bond O to CH2. This is a reaction that is partial hydrolysis, partial reduction to alcohol. You can write some examples. CH3, COOH in the presence of LiAlH4 is going to give you CH3, CH2, OH. Another example you can write propanoic acid or any type of acid. Okay, just write a note here. We have seen a reducing agent till now in alcohols chapter and aldehyde ketone salt, also that is sodium borohydride. Sodium borohydride, that is NaBH4, does not reduce carboxylic acid. Since it is a weak reducing agent. Write this much, let me know if you're done. Then we will look at What happens if I have what happens if I want to do a complete reduction to alkene? Done, guys, all of you? Yes or no?
No, sir.
Okay, wait. So all of these alcohols, they will be primary alcohols. Okay. So if you are going from carboxylic acid to alcohol, you will be always getting a primary alcohol. Yes, done, guys. Yes or no?
Yes, sir.
Yes, sir.
Okay. Complete reduction to alkenes. Complete reduction to alkenes. So for complete reduction, I need red phosphorus and high temperature. We'll have RCOOH with hydrogen iodide, which is a very strong reducing agent in the presence of red phosphorus at somewhere around 200, 200, so plus 200 minus 200. So around 200 degrees Celsius you need, that is 473 Kelvin. All right. Now this will give you CH3. Okay. What is important in this reduction? That you are going to get the same number of carbon atom as the parent carboxylic acid. You're going to get the same number of carbon atom. So if you have CH3, COOH plus HI in the presence of red phosphorus at 473 Kelvin, then you are going to get CH3, CH3. So the carboxylic acid is going to get reduced to an alkyl group. Write this down. Let me know if you're done. So RCOOH, it has two ways in which it can get reduced. Either it can use LiAlH4 or B2H6, or it can use hydrogen iodide in the presence of red phosphorus and some heat. It is going to give me alcohol, and more importantly 1 degree alcohol, and here I'm going to get a alkane. Here I'm going to get a alkane. This will be RCH2OH, will be RCH3. Then write this down. Let me know if you're done. Done. Okay. So write one more reaction, okay, in the same class, that is the
No, sir.
not done. तो
No.
जल्दी लिखिए, क्या हो गया?
Yes, sir.
Done. Okay. So there's one more reaction, but just note that it is not there in your NCERT, but it can be useful while we are going to do transformation from one compound to another compound. Okay. So write this. This is the third reaction that we are writing. Bromination of silver salt of bromination of silver salt of acids. That means carboxylic acid. This is also, it is also has a name, that is Hans Diker Unstiker. Unstiker reactions. So I'm just giving you the, okay, wait a second. Yeah. So if you have silver salt, that is, for example, CS3, COOAg, you react this with Br2, then you are going to get CS3Br. That is, we'll get an alkyl halide with one carbon less. Byproducts will be carbon dioxide, and you will also get AgBr. Important thing is that it can be used to prepare. Haloarenes. It can be used to prepare haloarenes if you have COOAg, then treat with Br2, and you're just going to get directly a bromobenzene. Okay, so from silver benzoate, you are getting bromobenzene in one step. Okay, again, there will be CO2 and AgBr. Then guys, all of you, yes or no?
Yes, sir.
Okay. Right, next, that is reactions involving alkyl group of carboxylic acid. The last type of reaction, that is Chari tha na? I think, yeah. Nahi hua hai kisi ka. Yeah, okay, fine. Abir. Yes, Abir. Reactions involving alkyl group of carboxylic acid. Okay. First reaction is halogenation. Halogenation, and it is also known as the name that is there, which is more important, Hell-Volhard. I think it is Hell or Hell 1L, I don't know. Hell-Volhard Zielinski, HVZ. And it is also known as a reaction HVZ reaction. Hell-Volhard Zielinski. Please write the statement. Carboxylic acids having at least one alpha hydrogen, it reacts with chlorine or bromine, in the presence of red phosphorus to give compounds in which alpha hydrogen is replaced by, in which one alpha hydrogen, you can say, alpha hydrogen is replaced by halogen atom. So if you have R, CH2, COOH, and you are reacting this first of all with X2 in the presence of red phosphorus. The second step, you need to hydrolyze this. That means give some water molecule, give some water. So what is going to happen? You're going to get R. This will be CH now, and the X will add on the carbon, that is alpha carbon, and you are going to get COOH. Okay, so this is the Helmholtz-Zielinski reaction, and this is alpha halo carboxylic acid. Alpha halo carboxylic acid. Okay. So this can be repeated also. You react once, so you will be replacing one of the hydrogen atom. You again react the same molecule that you have got as product now. Then you will be replacing the another hydrogen atom also. Okay, so write this down. Let me know if you're done. Done. Not done.
Yes, sir. Done.
Done.
No, sir, just a second.
Done, guys.
Done, sir.
Done. So see what can happen. You will have, for example, let us start with CH3, COOH, and I'm writing HVZ. So you will write these reactants, okay, X2 red P and then water. So we are doing Helmholtz-Zielinski reaction, and then you are going to get, first of all, let's see, let us add in Cl2. You know, in X2 we have Cl2, so you will get CH2, COOH, and there will be one chlorine atom. Then again you do same reaction, HVZ, and we are taking the halogen as chlorine, and you are going to get CH, COOH, and there will be two chlorine atoms. Further, if you do the same thing, then what will happen? HVZ, Cl2, then chlorine. This carbon has 3 chlorine atoms, and then COOH. Okay, so this can be repeated to n number of times. This can be repeated to n number of times. Now, what is very crucial regarding this compound, that is alpha hydroxy carboxylic acid, that this is now a haloalkane. This is now a haloalkane. If I look at this portion, right, I'm going to look at this portion, and it has a carbon halogen bond, and then this carbon halogen bond can show various reactions can show reactions that are similar to the haloalkanes. So if I react this with aqueous KOH, then I'm going to form R, CH, and this chlorine will be replaced by OH, and you will be getting COOH. Furthermore, if I am going to react this with ammonia, then what will happen? You will get R, CH, NH2, COH. So this is a synthetically very useful reagent. It is very useful reagent. Write this down. Then we will look at the last thing, that is the electrophilic aromatic substitution reactions. Okay, electrophilic aromatic substitution reactions of benzoic acid. Benzoic acid. Done, yes or no? Done, guys?
No, sir.
No. Okay. लिखे.
Done, sir.
The last reaction is electrophilic aromatic substitution of benzene. So it's one reaction, we have two. Electrophilic aromatic substitution. So first of all, let us see few reactions. Number one is bromination. So in bromination, we will have. So now you tell me, carboxylic acid is a active plus M group or minus M group? बताइए, भूल गए, सब भूल गए आप लोग. In the presence of FeBr3. I think I wrote you ना, I कल ही लिखा था शायद हमने. नहीं. प्लस एम या माइनस एम नहीं, कल नहीं लिखा था आप लोगों को. Last time नहीं लिखा था. Okay. This minus m ना, key atom. You guys don't remember at all what is plus m minus m, guys? How to identify plus m minus m?
No, sir.
Key atom, key atom, key atom. ये word याद है आपको? Key atom. नहीं याद है भी. Revise. Start revising. It is minus m group and it is going to form. नहीं, लोन पेयर में माइनस एम नहीं होता है. नहीं सानिया, दम गलत, एकदम like it's like very wrong. Lone pair does not mean it is minus m. So in this, you are going to get a meta product. Br will be attached here, and the byproduct will be HBr. Second, right, sulfonation. In sulfonation, sorry, this will be concentrated. H2SO4. You'll also need some SO3 in this reaction. Then it is going to form meta substituted H, and here you will be having SO3H. Sulfobenzoic acid. Third is nitration. COH plus HNO3 in the presence of conc H2SO4. You will get a nitro substituted benzoic acid. NO2. Okay, 3 nitrobenzoic acid. So these are the 3 reactions that are given by benzoic acid. But the important point is that, write a question. Carboxylic acids do not undergo Friedel-Crafts reaction. Why? Are you guys done till the reactions nitration? Yes or no? Done, guys? No. No.
So
Yes.
just
So right. There are 2 reasons. Number 1 reason is carboxylic acid Carboxylic acid is a very strong deactivating group. Second reason is that the catalyst that we use in Friedel-Crafts reaction, AlCl3 that is used as catalyst gets bonded to the carboxyl group. That gets bonded to carboxylic group, and the reaction doesn't occur. So these are the two reasons why carboxylic acid they do not undergo Friedel-Crafts reactions. Okay, so this is the end of the chapter aldehyde, ketones, and carboxylic acid. Okay, so you can you have like 5 days now. You can solve the questions. There are approximately how many questions? I think there are 20 questions in this chapter. Yeah, 20 or maybe more or less 20. So you can do those 20 questions and then we can discuss them in the next class, or we will start amine. Amine is a relatively small chapter, so we'll complete it relatively faster. Okay, so write this down. Let me know if you're done, guys. Done? Okay, I think done, everyone.
No.
No. Okay, right. जब पूछते रहते हैं तब तो आप लोग कुछ बोलते नहीं है, जब बंद करने का रहता है तब आते हैं। नहीं सर, नहीं। एक वर्ड भी छूटा है ना?
Done, sir. Done.
Okay.
Just the last line.
Okay. Thank you very much. So
Thank you, sir.
please do the questions, है ना? नहीं कीजिएगा तो it won't like nothing will stick in your mind. Okay, so please, you have your notes. Look at your notes and try to do the questions in NCERT, and in the next class I will discuss them. You will be coming with doubts. Okay,
Yes, sir.
I hope, I think, and I like what मेरा क्या trust है इसमें? आप ही बताइए. Like I'm not giving you questions, right? Can I give you questions? Should I give you questions? Tell me. बताइए. How will you work? Should I give you questions?
Yes, sir, that would also be fine.
Okay. So that
Yes,
will also be fine. So see, you must do a few questions. Okay, you must do a few questions from NCERT. (12.18), 12.19, 12.20. Okay, so these are must, because these are small, and that is why I'm saying that don't leave these questions. Don't leave these questions. And then 12.12. Yeah, so at least do these questions, because they don't rely on reactions and memorizations much. They are more or less, I will say, they are more or less logic based, है ना? So you'll be having in this 12.12, you will be ranking them in their reactivity. You will be ranking them in their acidic strength. Okay, then 12.18 is very important, because in this you have to give explanation for a few things. 12.19 is a long question in which you have been given the carbon organic compounds containing this much percentage carbon, hydrogen, different things. And 12.20, it is something that we have learned, and we have written the questions in our notes. You will find the same question in your notebook, so you just have to copy that, है ना? Because it is important. That is why I have given you 12.20. ये 2 marks में 1 marks में आ ही जाता है, like एक साल बीच छोड़ छाड़ के. ठीक है? Fine.
Yes,
चलो
sir.
guys.
So can you scroll up for a while?
Yeah.
More.
Which part? Tell me, na, sir.
Is the heading of this one. It's electrophilic. And the previous one was halogenation, right?
Halogenation, Helmholtz-Zelinsky reaction. Yeah.
Yes, sir. Yeah.